Here is another puzzle, a gas puzzle, genuinely approachable Sudoku by full deck and missing a few cards. This one has standard Sudoku rules in Kropki pairs, which is the black dots with a 2-to-1 ratio on either side of them, so either half or doubled digits, and white dots, which are adjacent to consecutive numbers. Not all dots are given. This one's called gas molecules. It looks, I suppose, like a chemistry, some drawings. I don't know, I never studied chemistry, so not any more than I had to, at least. Let's get going. Ooh, what a tasty start. We've got 3 black dots in a row, which means that this has to be something which has 3 lots of doubles available to it. 3 lots of powers, or 4 lots of powers rather. It can be squared, can be doubled 3 times, can be doubled 3 times. I'm saying powers because it's 2. Can't be 3 and 6, and the others don't fit. 5, 7 and 9. It's 2, 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3. So it's 1, 2, 3, 4, 8, or it's 8. Did I say 3 in it? 1, 2, 4, 8, or 8, 4, 2, 1. In some order. Okay. Right. We have something similar here. Oh, very similar in fact. So this is exactly the same but on its side. And we have the joys of another very similar feature over here and here. So what do we have? We've got some nice bits. We've got 2 4 pairs in the boxes, 1 8 pairs in the boxes on both sides. We also have 1 8 pairs in the rows and columns. That's about it for now. And 1 8 pairs in the bottom rows and columns as well. And tops. So there's a lot of symmetry going on. I'm just going to pencil mark in 1 3 5 for now. Although, straight away that can't be 1, can it? Because if that's 1, well, that definitely can't be 1. But if that's 8, then that'll be 4, that'll be 2, that'll be 1, and that'll be 8. Never mind, it can be 1. I take it all back. This set of 3 consecutive numbers can't come from the pool of 1, 2, 4, 8. The only consecutive numbers there are 5, 6, 7. That's all that's left over for us. Right. This digit can't be 1, 2, 4 or 8. Or 5, 6, 7. 1, 2, 4, 8, 5, 6, 7. So what can it be? It can be 3 or a 5. Okay. And where were we? This was 3 or 5. Which means the thing next to it has to be 1, either 2, 4 and 6. But of course that can't be 5 because there's a 5, 6, 7 pair and that can't be 6. So this is a 3. And we've got either a 2 or a 4 there. Just another 2 and a 4. We've got them in this box and we've got 1 each in the other box. This should be a 2 or a 7 or a 9. It can't be a 2 and it can't be a 7 because we've got a 2 paired, we've got a 7 and a triple, so it's got to be a 9, which fixes the order here. 9, 8, 4, 2, 1. That's a 1, 2, 4, 8. And this can't be a 9er because that would have to be an 8, so that's a 7 and a 6. Oh, and we're making steam. Oop, that's a 2. 1, 2, 4, 8. That's not a 1. That is a 1, 2, 4, and 8. This sees 1 and 8, so it can't have either of those in it. But we know this has got to be... Ooh, this could be something like 1, 2, 1 or 2, 4, 2. You have to be careful because these are in separate boxes. So let's not be hasty. We can say whether this is 3, 6, and it has to be this way round. Now that this was 2, we can say that this is 3. And we can't have 3, 6, 3 here anymore. It's not possible. Can't have 2 in either of those. So what is that? It's not 1, 2, it's not 2, 4, it's not 3, 6. That has to be 4, 8. That can't be 8. This is either 8, which is not. It's not 4, it has to be 2. So we've got 2, 4, 8. Okay, and this is either 3 or 5, which it could be either still. Interesting. We don't have an 8 here or a 4 here. We could have 1, 2. No, we can't, so this is 3, 6. And it's actually fixes the middle. So that has to be 5. Are they all that constrained? I hope so. So this can't be 3, 6 because of a pair. It can't have a 1 or a 2 in it. It has to be 4, 8. It has to be in this order. No, it doesn't. What's happened? Oh, it can have an 8 in it. Just, no, it can't. Oh no. So it can't be 3, 6 because of that pair. What's happened? Am I still alive? If you're seeing this, I'm still alive. So because there's a 4, 8 here, and we can only have 1, 2, 3 or 6 remaining, so we certainly can't have 1 and 2 in here. Is this wrong? Don't understand what's happened. Oh. We can have 2, 4 that way around. How did I not see that? Okay, well, we're still alive. Sorry, that was really weird. Alright, well, let's finish this off. This has got to be not 1, not 2, not 4, not 8. It's got to be 3 and 6 in this order. I think we're still alive. 5 and 7. Oh, lovely. Wonderful. We've used all the crop key digits, so now we just use Sudoku. I will say there's less completion than I thought at this point. Oh, clearly it's 5, 6, 7. That middle one has to be 6. Interesting. This has to be 4. That makes this 2. And now the wheels are coming off. 8 and 9. 1 and 7, which we can place. Hello. That's a 9. That's a 9, that's an 8. That's an 8. We might be able to fill in all our 8s now. Yes, we can. It's a matter of time. No one's safe. Three, 5. Okay. 5 and 6. 6 and 5. 1 and 2. And these are actually 1 placed here. 4 and 9. And we can place those. I wouldn't have thought to go there first. 5, 6, 7 could be any. This should give us some joy. Also, these are not exactly 5, 6, 7. That is 5, 7, and that makes that. That's 5, 6, 7. It's got to be a 6. No. We're missing another number. It's not just 5, 6, 7. We're also missing 3. And that can be a 3. 3, 5, 6, 7. Okay. These two can be 1 or 5. No, not 5, but it can be 1 and it can be 9. 1 and 9. Sorry, 5 and 9. That hasn't resolved itself just yet. Now those are all linked. 5 and 6 in this order. That's getting us somewhere. That's a 5. That's a 7. That's a 6. Whew. Smoking. One, 3, 7. Can I do anything with these? I can place a 3 and then a 7 and then a 1. No one can stop me. 2 is between these as well as 4. We can place the 4, and hence the 2. That settles these. That gives us 1 here. Then we've got 7 and 6. That's a bad one to mess up. 9. And we get a final time of 14:42. I hope you had some chemistry with me. That was gas molecules. See you next one. Next time, next one, next time.